Jeopardy Chemistry Edition. I'm Alex Trebek, and let's check back in on the contestants. In first place, with 273.15 points, we have Kim Jong. Welcome, Kim Jong.
Fast! Okay.
In second place, with negative 101.3 points, we have Tom Cruise.
Thank you. This guy.
And on to third place, with negative 6.022 times 10 to the 23rd points, we have Sean Connery.
Think you're real smart, Trebek, don't ya?
Thank you, Mr. Connery. And let's check back in on categories. Our categories tonight for Double Jeopardy are magnetic properties, atomic radius, potent potables, ionization energy, obese women in the 21st century, electron affinity, and periodic properties. All right, Mr. Jeong, you have the board. Please pick a category.
I'll pick periodic properties.
For how many points?
For 400.
All right. Please explain the acidic, basic, and amphoteric nature of the third period elements. Yes, Mr. Cruz.
It's, oh God, I got it right here. Steel trap, right here, okay? I got it.
I'm sorry, Mr. Cruz, but you were wrong. You have the answer, Mr. Jeong.
Yes, I do. From left to right, it goes basic, amphoteric, and acidic.
That is correct. Way to go, Mr. Jeong.
Okay, so the question asked to our contestant was, explain the acidic, basic, and amphoteric nature of third period elements. So for an example, for the third period elements, we have magnesium, aluminum, and sulfur. Magnesium oxide plus water results in a solution of magnesium 2+ ions and a hydroxide minus ions. Hydroxide results in a basic solution, so magnesium is a basic oxide. Moving on to aluminum. Aluminum is amphoteric, which means it can act as both an acid or a base. When you add it to HCl, it's acting as a base, as HCl is acid, and it results in a neutralization. When you add it to NaOH, the NaOH is the base, and the aluminum is an acid, and it also results in a neutralization. So aluminum is amphoteric. In terms of sulfur, sulfur dioxide plus water results in sulfuric acid, which is an acid. So if we want to look at the trend of third period elements, we say that from left to right, the nature goes from basic to amphoteric to acid.
All right, Mr. Jeong, please pick another category.
Ionization energy for 200.
All right. What ion?
I had an eye on your mother last night, Trebek.
That was not necessary. We're just going to move on from here. All right, Mr. Cruz, you have the board. Please pick a category.
How about electron affinity for 2,000?
All right. Your question is, explain why the noble gases do not tend to have any electron affinity.
It's simple. They just don't want electrons, you know? It's too simple. It's too simple. It's too simple.
You know, that is acceptable. I will give you the points for that, Mr. Cruz.
This guy. Look at him. Perfect.
All right. The question asked in Jeopardy was, explain why the noble gases do not tend to have a negative electron affinity. To first answer this, electron affinity is the ability for an element to attract electrons. So, since the noble gases are in the 18th group, they're very stable since the p orbital is already completely filled. So, in order to attract a new electron, they would have to send the electron to a new s orbital. And this is unfavorable because it would actually require energy to do so, which is why the required energy would actually make it positive, which is why it is impossible to have a negative. All right, Cruz, back to you.
Let me take the magnetic properties for 800.
All right, your question is, which element is magnetic, carbon or magnesium?
Titanium.
Connery, that isn't even an option.
That's not what your mother said last night, Trebek.
I got it.
Carbon.
That is correct. Way to go, Mr. Jeong.
All elements are either diamagnetic, meaning they have no unpaired electrons, or paramagnetic, meaning they have unpaired electrons. In the case of our Jeopardy contestant's question, The question was, which exhibits magnetism? Magnesium or carbon? Magnesium has 2 valence electrons, so it fills its 3s shell. As we can see, there are no unpaired electrons, making it diamagnetic. Because it is diamagnetic, it does not exhibit the phenomenon of magnetism. Carbon, on the other hand, has 4 valence electrons. Thus giving it 2 unpaired electrons in its 2p orbital. This makes it paramagnetic, and it shows the magnetism that it
Alright,
exerts.
Mr. Jong, you answered correctly. You have the board.
I will go with atomic radius 800.
Alright, your question is, organize the following elements by increasing atomic radius. Aluminum, phosphorus, chlorine minus, argon, and potassium plus.
Came across something like this in your mother's bedroom the other night, Trebek. Believe it's potassium ion, argon, chlorine ion, phosphorus, aluminum.
That is actually correct, Mr. Connery.
Damn right it is.
The periodic trend of atomic radius is explained by increasing atomic radius down a column and decreasing atomic radius down a period of the periodic table. This is because as you go down a column, an extra energy level of electrons is added, and therefore the atomic radius is larger. As you go down the period, it adds a proton and an electron with every element. However, the effective nuclear charge increase by adding a proton is a lot more effective on the radius than adding an electron, so therefore the nucleus is able to hold the electrons in tighter and create a smaller radius. In the event of the Jeopardy contestant's question, the answer from smallest to largest radius would be the potassium ion, argon, chlorine ion, phosphorus, and then aluminum. For this particular answer, the first 3 are isoelectronic species, so therefore all of them have the same amount of electrons, so the atomic radius is going to be dependent on the number of protons in the nucleus. Since potassium has the highest number of protons, its effective charge is much larger and it allows it to pull it in tighter. The same goes for chlorine because it has the largest number of electrons out of the 3. The nucleus is not able to pull it in as tight and therefore the radius increases. For phosphorus and aluminum, it just follows the periodic trend. From right to left, the atomic radius increases.
Unfortunately, since Mr. Connery got the last question right, the board is yours.
I'll take Alex Trebek's mother in the 21st century.
My mother is dead.
Must have been from the obesity, Trebek.
Wait, where's Tom Cruise?
Tom Cruise! Ah!
Alright, it is time for Final Jeopardy. For Final Jeopardy tonight, our question is, you know what, screw it. Just write a compound, a chemical compound, alright? Simple enough? Go. Alright, your time is up. I will start over here with Mr. Connery.
No, me, Tom Cruise, right here, Tom Cruise.
Alright, Mr. Cruise, if you must. Tom Cruise, you answered goose. This is not Top Gun.
What? Top Gun. What? Come on.
Let's see what you wagered. It looks like you wagered 2 YOLOs. What is a YOLO?
You only live once, Alex. Come on, Trebek, come on.
I'm moving on. I'm moving on to Mr. Connery.
Trebek.
Your answer, Mr. Connery, it looks like it says boobs. Is this your answer?
Yes, Trebek.
And you wagered my mother. Really? Mr. Jong. H2O. You got one right. You got one right. And you wagered, it looks like $3.50. Is that it?
No, triffic.
I see. Well, we have our winner for tonight. Thank you.